Hi folks, so the question we're going to do in this video is a question from the 2018 Junior Cert paper, and it is a question here based on the topic of transformation geometry. So it says here, the figure shows a logo for a locksmith shop. The logo is subject to transformations in the following order. We have to do an axial symmetry from P to P1, so if you look at the locksmith, or sorry, the key here, where we've got point P, we have to do an axial symmetry from P to P1. We have to do a translation from P1 down to P2 and a central symmetry from P2 up to P3, and then rotation clockwise about point O until P3 reaches the line OL. Okay, so starting off, where we're going to do is we have to kind of position this on the page where we think it's going to, I suppose, roughly fit. So where I'm going to draw the key is roughly up here on the top left of my page. Okay, roughly up around there. And then I'm going to locate P1. So starting off by looking at the key, you can see we've got a circle here which has a radius of 20, and then from the center point all the way out to P, it's a distance of 40 plus 20, so that distance from there to there is 60. And then from P, you can see it tells us as a height of 20, so we're going to go from P up 10 and down 10 and kind of create this rectangle, and then following the lines inside here to kind of make the pattern. Okay, so on the top left of my page, I'm going to start off by drawing in a key. So I'm going to go start about here. So roughly there on the top left of my page. So just doing a horizontal line. I'm going to zoom in on that there now. Okay, now because I've done the horizontal line, I'm going to pick to start off a center point. Pick a point about here. And from that center point, I'm going to measure a distance out of 20 millimeters. So now that I've done that, very lightly, I'm going to draw in my circle, which has a radius of 20. I'm just going to do it ever so lightly. So there's my circle, which has a radius of 20. And then from the center, I'm going to measure out a distance of 40 and then 20. So from the center point, I'm going to measure a distance out as far as 40. And then another 20, which gets me to 60. Okay, that's my point P. Going to do a light line up and down now. And from that point there, I'm going to measure up. So if I put my 7, you can see the 7 centimeter mark on the line. I'm going to measure up 1 centimeter, which will bring me up to 8. And 1 centimeter, which will bring me down as far as 6. Okay, so now that I've that done, I want to do a nice light line across, light line across. Okay, so what we're going to do now, I'll just put in the axes of the circle actually now while I'm at it as well. So just finish those off. So we have the rough shape of it that we want. Just going to label this point here. That there now is my point P. Okay, but now that I have the rough shape of it that I want, what I want to do is I want to heavy in the rest of it. So you can see here, and what I'm going to do is I'm going to break it down into kind of like clock positions. Okay, so if this was 12 and this was 6, well, where would this be? Well, if we imagine 1 was here, this would be 2, this would be 3, and this would be 4. So 2, from position 2 on the clock, connects all the way over to the bottom underneath P. Okay, from position 3, it connects to where the 40 millimeter line, okay, is in the bottom. And from position 4, it connects up to the top of that line. So, as I said, step 1, from position 2 on the clock, it connects all the way over to this point, just underneath P. From position 3 on the clock, it connects to the bottom of where the 40 millimeter mark. So remember, from the middle, I measured 40 millimeters right to here. So now from there, I'll do a line up and down. From position 3, it connects down to here. So click that, position 3. And from position 4 on the clock, it connects up to there. And that's starting to build up the clock face for us. Now, next little part, from this point down here, we can clearly see that it goes up to the top right, and through that then we will get a line here, okay, where we're going to make this triangular face then. Okay, so from this position right here, I'm going to connect it up to this point. And what's helpful about that line that I just did, where it cuts through the middle here, right there, I'm going to do a light line up and down and connect it to P. That then helps me heavy in my detail. Now, for the purpose of this video, I am going to use a marker. It's a little bit on the inky side, but it'll do fine. Just taking my time with it. And all we do every time we complete this is follow that sequence. So that is the first one. Once again, into P. And then there is our key shape. And now, just using the attachment on my compass, now I'm going to actually heavy in the circle as well. So there we have it. There is our key figure. Now what we have to do is we have to do an axial symmetry from P to P1. So going back to my sheet here now, when I look at the dimensions, zoom out there a little bit. So I have to do an axial symmetry from P to P1. So first of all, we have P, I have to locate P1. So from P, how far down is it? Well, you can see here it's a height of 20, okay, but P is in the middle of that, so therefore I'm only going to measure down. If you imagine there, half of 20 is 10. So from P down to this point here will be 10, and from this point down, as far as P1 is 50. So therefore, 10 plus 50, from P I'm going to measure down a distance of 60. So I added two of those. And then from P, I'm going to come in a distance of 30 millimeters to find P1. So down 60 and in 30. Okay, so from P, do a line down. And on that line from P, I'm going to put the 6 on it. Mark down as far as 0. Make my little mark there. Do a light line out. And on that line out, I'm going to measure a distance of 30 millimeters. And right there, I have now located P1. So, label that now as well. That is P1. So, what is the stage here? We have now located P1 and we want to do an axial symmetry, so clearly I have to create an axis. So I'm going to connect P to P1. That's step number 1. I'm then going to bisect that line, and that bisector will become my axis. So pick a distance slightly greater than halfway. Put your compass on P1, swing the arc, and then put it back on P and swing the arc. And where the axe is, or where the arcs cross each other, will help us locate our axis. There we go. And that there is my axis. Now all the points are going to project out perpendicular to the axis, or in this case, parallel to the line P1. So the 2 points that I really need here are the points, the center point of the circle and P. And P has already been given to us, okay, because I know P connects to the center, and we're going to use parallel and perpendicular lines to help us after that. So using P to P1 as my guide, put my set square on that. Just zoom out here so you can see it a little bit better. I'm going to get my other set square and put it underneath it, and then slide it all the way across until it gets to the center point of the circle. When it gets to the center, project out, perpendicular, then zooming back in. I'm going to take the distance from the axis, to the center of the circle, swing it out the opposite side. I have now found the new position. I have now found the new position of my center. And either the center connects to P. So I'm going to just do a little line like that. And then what I can do is I can take the previous radius from the original circle, or I could just measure 20 once again. So I'm just going to measure 20 out as far as there. and using the center point, redraw my circle. Try and do it without slipping like I did there. So there we have it. There is the center. Now, the next bit I want to do is I want to kind of create this rectangle here once again. Okay. Now, what I'm actually going to use is this center line from P to the center as my guide. Because if you look here, and we come back up to the original one, when P was connected to the center, the rectangle, okay, was perpendicular to that line. Okay, because through P, we had a line here, and it's clearly going perpendicular to it, where it's going vertical. So I want to go perpendicular to this line here. So how do I do that? There's a couple of ways you can do it. I'm going to show you here. One way, you can put the long edge of your 45-degree set square on the line you want to go perpendicular to. So you can put the long edge of the 45-degree set square on it, put the other set square underneath, and simply rotate the set square and then move it down as far as P1. Okay? The opposite way that people often like is if you put one edge of the 45-degree set square opposite. It doesn't matter which side you use. You can either use the number or the non-number side, but not the long side. So I'm going to use the non-number side here. Put it on it like this. Put it on the line you want to go perpendicular to. Put the other set square, the 3060, underneath it. And then simply slide it across until you get to the other side. And then through P1, I can draw a line. And that line then is perpendicular. Now that I have the perpendicular line, it's really easy for me to measure. We know the distance is up 10 and down 10. So from P1, I'm going to measure up 10. And once again, down 10. And everything then is going to go sliding set squares parallel to the P1 to the center line. So project this across. Project this one across. And there we go. Now distances out, once again I have to create those distances to get that little pattern. So from the center, we have a distance out of 40 millimeters as well. Remember, from the center up here was 40 out. So I'm going to do the exact same thing. Okay, and parallel to that line there. Okay, so that's my method. Now I'm going to follow the steps that I did before, which was connecting the 2 o'clock position to the end, the 3 o'clock position to here at the bottom, the 4 o'clock position to the one here at the top, and then this one here connected up to there. And all we're required then is, you can see where it cuts through this point right here in the middle, bit of sliding set squares parallel to the perpendicular line, once again, going through the middle like that. And there we go. And now I can connect P down to this point and P up to this point. Now I find that the most accurate way by just bringing those lines across, because once I had my P1 point and the center point, everything was either perpendicular or parallel to that then as well. Okay, if you started projecting all these, it would work, but it can get a little bit tricky to be 100% accurate. Okay, so having in all this information once again, I just find this the way that helps me be the most accurate. So that comes down as far as there, into there. Let me just continue in this sequence. Then this last little bit here. Okay, and then once again, just switch out the lead of my compass for the marker. And we're moving on then to a translation. So there we have it, folks. That there was the axial symmetry from P to P1. Now what we're going to do, as I said, is we're going to move on to a translation. Sorry, zooming out the wrong way there. This a little bit further into the screen. Right, now I have to find P2. So if I come back to my sheet, I have to locate where P2 is. And from P1, I can see P2 is over here. So what distance is it? Well, it's over a distance of 55 plus 35. So if I add the two of them together, that'll add up to 90. 55 plus 35, excuse me. And then from the P1 line, it's down a distance of 25. So I have to measure over a distance of P1, from P1, a distance of 90 and come down 25. So from P1, I'm going to continue that line across. And then from P1, I'm going to measure 90 millimeters. And I'm going to go down 25. And that will give me P3, or P2, sorry. So this point right here is now P2. And all I want to do here is I want to do it by translation. Now the nickname for this one, often teachers might call it, is train tracks, because everything is just going to move parallel from the distance from P1 to P2 and at the same length as well. So if I connect P1 to P2, if I get that distance on my compass, keep it set on my compass, so look, P1 to P2, keep that distance ready. And now all I want to do here is a little bit of sliding set square, so parallel to the line P1 to P2. And as I said previously, the most important point that I actually need here is the center point of the circle. So I'm going to go down to the center, parallel to that line there, P1 to P2. Once I get to the center, do a line out. And now I take the distance from P1 to P2, put it on the center, and I mark it. And once again, the same sequence. I'm going to connect the center up, and then I'm going to measure from the center a distance of 20 millimeters. So that will start off by giving me my circle. Put my compass on the new center, the new position of the center. Pencil on the 20. There we go. I'll zoom in on that there now. So you can see I've done the circle, and now we have to follow the exact same sequence. So I can put the edge of my 45-degree set square on it, on the line I want to go perpendicular to, which is the one connecting P2 to the center of my new circle. And if I put that edge on it, and then I slide it across till I get to the opposite side, I get a line. And then on that line there, from P2, I'm going to measure up 1 centimeter along that line and down 1 centimeter. Okay, from the center, I'm going to measure out a distance of 40 millimeters. And everything seems to be staying in, it's bang on. Yep, so 40 millimeters. As far as there, you can see the little mark that I've done. Now, once again, just using my set square, I'll slide it along. I'm going to do my parallel line first, my other parallel line, and then do my perpendicular line through this one. And same sequence. So from 2 to the bottom, that's my 2 o'clock, and 3 o'clock to the bottom, and the 4 o'clock position to the top, and then this one will connect here, and through that point then we have to find the point up and below it. So once again, put your set square on it, through this point right here in the middle, do a line up and down, and we're at the top here, I'll connect it to P2, and at the bottom. And there we go. Once again, it's just a case of heavying in our information. So, just with the marker, I'll take my time here. Obviously, if you want to move on to the next one, by all means skip ahead, while I'm just heavying this in. There we go. There we go. Okay, and last little bit now, just heavying in the circle. So there we have it, folks. Now we're going to move on to the third part of the question. Zoom out there once again. Now to move on to the third part of the question, whereby we have to get a central symmetry from P2 to P3. So once again, we have to locate P3. So from P2, where is it? Well, from P2, it's back 35, okay? And above the line from P1, which we already have, I can measure up an additional 35. So it's back 35, up 25, and up 35. So technically, it's up 60 from P2. But I've already got a line here, and it's 35 millimeters above this line. But from P2, I have to go back from P2, back 35, and then up from that line. So from P2, I'm already up there at that distance. So from there, from that point right there, I'm going to measure back 35. Gets me to there. And then I'm going to do a vertical line and go up 35. Okay, so on that line, I'm going to measure up 35. So I'll just use the 10 as my guide. So from the 10 mark, I'm going to go up to 13.5. So there we go. That point right there is now P3. Just going to flip over. So, okay, I've now got P3. So I have to do now a central symmetry. So for a central symmetry, what I'm going to do is I'm now going to connect. Bring it into our screen so we can see it a bit better. P2 to P3. Connect the two of them. And I have to find the midpoint of that line, because that midpoint will be my point of symmetry, or in this case, my point for central symmetry. Everything's going to go through that. So from P2, pick a distance slightly greater than half the line, swing an arc, the exact same from P3. Okay, now that I've done the arc, connect the 2 points where they cross. Okay, that point right there in the middle is going to be my point of symmetry. I'm just going to call that point C. Okay, now the point that I want to find, as usual, is the center point. So from my center point, I'm going to go through C. Okay, so it's gone through C. I just need to extend it out now to the opposite side. So what I'm going to do is I take the distance on my compass from C, which is my point of central symmetry, and I want to find my new center. So I put it on the original center, which is down here, and I mark it out to the opposite side. Okay, now that I found my new center, I'll connect that to P. Okay, step number 1. Okay, now that I've got my new center up here, I'm going to measure a distance of 20 millimeters on that line. So from the center, I'm going to mark down along the line 20 millimeters. And step 1, I'm going to redraw my circle, radius 20. Just following the original plans. So there is my circle. Now from the center, I'm going to measure out a distance, or I can actually even measure back from P, but from the center, just actually have to move my visualizer here a little bit. So from the center, 60 millimeters, perfect, I'm happy with that. But from the center, I'm going to measure a distance of 40 millimeters as far as there. Okay. Now, a bit of sliding set squares here. What we're going to do is I'm going to put the 45-degree set square on it, the non-number side. Okay. And step number 1, put the other set square underneath it. You've seen me do this previously, just like that. So this line, I want to go perpendicular to that line there. So I'm going to slide it all the way across until I get to P3. Make sure the set square underneath doesn't move. Do my line like this. While I'm at it, I'll also do one from the 40 millimeter mark. Okay, now that I've done those two lines, zoom back in. From P3, I'm going to measure up 1 centimeter and down 1 centimeter. Okay, same concept. Now what I'm going to do, just a bit of sliding set squares, parallel to this line, slide it across. Okay, there we go. That is our rectangle. Now what we have to do is we have to complete the pattern like we did down here. Now, this has been flipped and inverted. So if you're getting confused, if you remember my sequence of kind of going with the 2 o'clock, 3 o'clock, 4 o'clock, then this became 2, 3, 4, and this one, 2, 3, 4. If you're trying to wonder which one of these is the 2, 3, and the 4, well, obviously the 3 is in the middle, but which one is the 2 and the 4? So what you could do is, if you knew what one of them down here, which was, let's say this one here, this was the 2, you could go through the C and guide it, and you can clearly see that that is obviously now my 2. Okay, and from the 2, I know it connects to the opposite side of the rectangle. So therefore, from this point here, working the opposite way now, from the 2, I'm going down to here. From the 3, I connect to here. And from the 4, I connect up to here. Okay, then from this point, I connect it to this one. Okay, and now, once again, just a little bit of sliding set squares, parallel with the perpendicular line, parallel to that line, through this point here, right in the middle. And then, at this point here, we'll connect to P3, and likewise with this one. So there we have it. That is our pattern completed. It's simply a case now of heavying in the shape again. So just take my time using the marker. There we go. You can see there, I just don't want the ink to run. Did it again. Doing this bit. Okay, and the last little bit now, just switching out heading my compass. Okay, and here is our central symmetry. And there we have it, folks. There is our central symmetry from P2 to P3. Okay, that is the third aspect of the question done. Now what we have to do is we have to move on to the final part of the question, which is a rotation, often the trickiest part. Okay, so getting back to the sheet here. It says here we have to do a rotation clockwise about point O, so they give us point O on the sheet, until point P3, which we have now, reaches the line OL. Okay, so we have to rotate clockwise. That means the object is going to go in this direction, not this one, but in this direction. Okay, until it hits the line OL, and OL has an angle of 30 degrees. So first of all, I have to find O. Okay, so where is O in relation to any of the other points? Well, it's clearly on the same line as P1. Okay, so we have that line, and from P2, you can see here there's a distance of 35 millimeters. Okay, so that's what I'm going to do. From P2, I'm going to measure over a distance of 35 millimeters along that line on P1. So on the P1 line and above P2, I'm going to measure a distance of 35 millimeters. So from this point here, really easy, 35 millimeters to there. Now I've now located the position of O. Now that I have the position of O, I'm going to draw in my line for O, which is going at an angle of 30 degrees. Okay, and that is the line OL. So there's my line OL. Now what I have to do is I have to do the rotation. So everything is going to rotate about point O. But what they tell us specifically is rotate the object clockwise about point O until point P3 reaches the line OL. So that's what we're going to do. So I'm going to rotate P3, and essentially I'm just trying to find P4. And then I'll try and find the center and everything else about it after that. So put your compass on O, put the pencil on P3, and P3 will rotate until it hits right there. Okay, and at this point I'm going to call that P4. Okay. Now, the other point that I'm going to rotate is the center point. I'll put my compass on O, put the pencil point up to the center, and the center is going to rotate. Now, based on my own understanding, I think the center, because P3 rotated here, the arc will have to be roughly the same. Now, the easiest way to find the center, okay, is if I put my compass on P3 and take the distance to the center, which is 60 millimeters like that, on my compass, I take that distance, well then, where P4 is, which I've now located, the center would have to be the same distance away. So if I put my compass now on P4 and swing an arc to cut that one, and the center point had to be along that arc where it cuts the arc, that has given me my new center. Okay, that is the easiest way to find it. I'm now going to connect the two of them up and continue on in the same sequence. So from there, my new center is here. Step number 1, I want to measure the distance of 20 millimeters. Doesn't matter which way I measure it. Drawing my circle, my new center, radius 20. Okay, there's my new circle. Now, from the center of that one, I'm going to measure out a distance of 40 millimeters along this line. There's there. And what's important is, on this line here, that's the line I now want to go perpendicular to. Okay, so if I put the number side of the set square, of the 45 degree set square on this line, from P4 to the center, and all I'm going to do then is put my other set square underneath it and simply slide it across like that. And from P4, I should be able to do a line like this. Now, what's helpful about that line then is, we know we're going to measure 10 and 10 either side of it. So from P4, I'm going to measure 10 to the right, and from P4, 10 to the left. Okay, same principle. Put the number side of the 45 degree set square on it. I can get all my lines drawn here now. Watch this. Slide it backwards, I can do this line. Slide it forwards, I can do that one. And then slide it forward again, and I can get to the 40 millimeter mark and go perpendicular. And there we have it. Okay, now same principle is going to apply here. Which one is 2, which one is 3, which one is 4? Now, in my opinion, I think this one will be the 2. So I can just check it. Hopefully we'll get close enough. So I can put my compass on O, can put my pencil, let's say where the 2 o'clock position was, because I knew where the 2 o'clock position was in this one. And if I rotate it around, hopefully it'll end up being close enough to it. Yeah, look at that, right through it. My accuracy is bang on. Okay, so there we go. So I know this one is the 2 o'clock position. Therefore, from the 2, it connects to the opposite side. Then the 3 goes down to this one. The 4 o'clock one goes to this one. This point here will connect diagonally up to that point. And then where it cuts through the middle, I've got a point there. I now want to go sliding set squares. Doesn't really matter which way I do it here. Just like that. Okay, and I'm going to connect this guy there and to there. So there we have it, folks, pretty much done. It's just a case, once again, of heavying in the details. I'm trying to do it neatly without the marker bleeding. So I was there. Okay, so there is the key shape. And finally then, to finish off the question, get in the actual circle. So there you have it, folks. Just put that stuff there off the table. So that there, guys, was the 2018 Junior Cert Transformation Geometry question. Okay, quite a little tricky one, obviously, when you consider the awkwardness in getting the actual kind of key shape here and trying to be accurate. And you can see here, I really only focused on the center point and point P and used the principles of parallel lines and perpendicular lines to keep me accurate as I went along. And you can see there, the shape did stay obviously the same the whole way out through it. Okay, you could have done it the other ways by bringing out every point, but then as you work through each transformation, it can become more and more difficult to be 100% accurate. Okay, but there you have it, folks. That is the question complete. Hope you found that helpful.